Hello student, today we are going to see how to find the centripetal acceleration. Okay, so centripetal acceleration formula will be, it is v square by r. Today we are going to derive how we got v square by r. Okay, I am taken, the object is moving in a circular motion, 2 point I am taken a b. Okay, the angle between these 2 points I am taken as a d theta. Okay, so this side is a v velocity, it's initially v velocity. Okay, only velocity in x axis, initial velocity in x axis will be v. Okay, initial velocity in y axis will be 0. Okay, because I am not given any velocity in y axis, I am taken as a 0. Okay, so I know initially at point of a, velocity of x axis, initial velocity of x axis will be 0, initial velocity of y axis will be initial velocity of x axis will be v, initial velocity of y axis will be 0 at the point of a. Okay, so at the point of b, okay, in circle, tangential line is going to represent the velocity, what is the resultant velocity. Okay, so in circular motion we are finding what is acceleration. Now at the b point, this side will be the velocity, v velocity. Okay, from x axis, this is the angle d theta, this angle will be equal. Okay, so it is a adjacent side of the, I am taken as a small triangle. Okay, it is adjacent side of the triangle, it is opposite side of the triangle. Okay, I am drawing that point, b point here, it is a v velocity, it is a velocity in x axis, final velocity in x axis, it is a final velocity in y axis. Okay, so this is a d theta. Okay, opposite of this triangle, this much, adjacent of this triangle will be this much. Okay, so adjacent by hypotenuse is equal to cos theta. So cos d theta I am taken. Okay, so this is in this triangle, adjacent is this much. Okay, so adjacent is equal to, our hypotenuse is a v velocity, Okay, so adjacent is equal to v times of cos d theta. So I got velocity at x axis will be velocity at x axis, that means adjacent side velocity will be v cos d theta. Okay, velocity at y axis, what about the velocity at y axis? It's the opposite side. Okay, so opposite by hypotenuse is equal to cos, it's a d sin t theta, that I am taken as a sin d theta. It's a small angle, very small angle. Okay, opposite is equal to hypotenuse times of sin theta. Our hypotenuse will be v. Okay, so v sin d theta. At the point b we are discussing, at the point b. Okay, so at the point b, final velocity at y axis will be v sin d theta, and final velocity of x axis v cos d theta. Okay, so we have two equation, velocity, final velocity at y axis, final velocity at x axis. Okay, at the point of b, velocity at x axis will be v times of cos theta. At point of b, velocity at y axis, that means upwards. Okay, v times of sin theta. Okay, final velocity of both the point. Okay, initial velocity of x axis v, initial velocity of y axis, we are not given any velocity in y axis, it's a 0. Okay, it's like a tangential line perpendicular to this line. Okay, now see here, as we know sin theta, it's when it's become as a very small angle. Okay, we'll take it as a very small angle. Okay, sin theta, if in case very small, you should take it as a theta. Okay, in case cos theta is very small, you have to take it as a 1. Okay, tan theta is very small, you have to take it as a theta. Reason, cos 0 will be 1. Okay, sin, it's 1 degree, it's going to represent, it's the same thing, whatever you will get radian, the same value you will get it. Okay, 0.01745 radian. Okay, 2 degree also same, till from 0 to 5 to 8 degree we will get as a angle as a very small. Instead of doing as a sine angle, you can do direct value of radian. Okay, so tan also will be the same. That is the meaning, sin theta is equal to theta, tan theta is equal to theta, cos theta is equal to 1. Okay, so cos theta approximately equal to 1, sin theta approximately equal to theta. This is the equation we got. Okay, now we are going to do change in velocity of x axis. Okay, that means initial velocity of x axis, final velocity of x axis minus initial velocity of x axis. What about the final velocity of x axis? Final velocity of x axis v cos theta, final velocity, initial velocity of x axis is v minus v. Okay, change in velocity. Okay, cos theta, as already said, cos d theta, you can take it d theta small angle. Okay, it's going to be a very small, cos theta will be 1. So v minus v answer will be 0. The change in velocity in x axis will be 0. Okay, what about change in velocity of y axis? That means y axis will be this side, v sin theta, final velocity, initial velocity will be 0. Okay, So final velocity of y-axis minus initial velocity of y-axis. As we know, final velocity of y-axis v sin theta. Okay. So v sin theta, that is d theta, very small angle, minus 0. Okay. So sin d theta, sin theta already I said theta. So dvy, change in velocity in y-axis, v times of d theta. Okay. Sin theta will be approximately equal to theta. So d theta will get. Okay. So now differentiating this equation, differentiate with respect to time. So just I am doing with respect to the time. So dvy by dt and velocity d theta by dt. So linear velocity by time, we can take it as a angular acceleration. Velocity by time, velocity by time, linear velocity by time, it's a linear acceleration. Velocity, angular displacement by time, angular velocity. Okay, it is acceleration velocity by time. Here angular displacement by time, it's angular velocity. Okay, as we know theta is equal to so far we got this much equation. Further I am going to proceed the equation. So we are going to continue from here. A is equal to v omega we got. Actually A is equal to v square by r only final equation. Okay, still we are not finding the final equation. Okay, theta is equal to d theta. It's in rotation motion. It's an angle of rotation. It's a d theta. Ds is arc length. Radius is r. Okay, so d theta is equal to ds by r. Okay, same equation. ds into r is equal to d theta. Just we have d theta is equal to ds into r. Okay, so same equation differentiating with respect to the time. Okay, d theta by dt into ds by dt. Okay, so see here, theta is equal to s by r, s is equal to theta times of r. Differentiate with respect to the time, ds by d theta dt and d theta by dt into r. Okay, it is velocity into omega r. So omega is equal to velocity by r. So velocity is equal to omega by angular velocity is equal to velocity by r. Okay, linear velocity by r. I know a is equal to v omega. Omega I found is a v by r. So that means v by r, v square. So centripetal acceleration in circular motion, v square by r. Otherwise you can take it v is equal to omega r. So omega square r square divided by r. So you will get it as a omega square r. Okay, so see here, theta is equal to s by r. How I got? Because in circular motion theta is the angle and s is the arc length, r is the radius. Okay, this is one of the relation in circular motion. Thank you.